Hello folks, let's continue with the next video where we are going to take the 15th problem of this exercise 7.2. The problem is there on the board. It says that we have I as the integral to be found out as x over 9 minus 4x squared dx. So it's very clear to us that amongst x and 9 minus 4x squared, 9 minus 4x squared is a better complicated function. So that we can go in for a substitution. So let's right away go with the substitution. Let u be 9 minus 4x squared. So when you take the derivative, du over dx is going to be 9, has no derivative. Derivative of x squared is going to be 2x. So that's going to be minus 8x. And since we require the x dx, so let's bring the minus 8 on the other side and retain the x there. So that you get it like du over minus 8 to be x dx. Now, let's revert back to the I, and I will have x dx getting replaced by minus du over 8. So, and this is going to be u. So it's very clear to us that this is going to be log modulus u plus c. So that's going to be minus 1 over 8 when we revert back 9 minus 4x squared, log modulus 9 minus 4x squared plus c. That's it, as simple as that. That's quite a simple function. So that's how we get it. Sometimes we also do this is a negative sign. You can take it as an exponent over here and call it as 1 over log. That also can be done. They are all equivalent forms of the answer. That way also it can be done. So we can quickly move to the 16th problem after this 15th one is over. It says that we have I as e raised to 2x plus 3. Another very simple function. I equal to integral of e raised to 2x plus 3. Had we got integral of e raised to x, we know the integral is going to be e raised to x itself. But here it is e raised to 2x plus 3. So another equivalent form. So let's see now what we can do over here. So to right away, let's start with u as 2x plus 3. Then in that case, you have the derivative on both sides. So it's going to be derivative of x is 1. So only 2 left and 3 doesn't have a derivative. So that's going to be 0. So therefore you have the overall derivative only as 2. Since we require a dx here, we can always write du over 2 as dx, and we can revert back to I. I can become e raised to u now, because 2x plus 3 is u, and dx we replace by du. As I told you, we cannot have x and u together. So either we have everything in x or we have everything in u. So we are converting everything in terms of u. So you are having e raised to u du. Now, let's get the integral. E raised to u plus c, we know for e raised to x, it's e raised to x. That's it. So, your integral is, no wait, we had to account for the u there, du over 2 actually, du over 2. So, that's half times, the 1 over 2 comes out, and e raised to u integral is e raised to u itself. So, it's going to be half times e raised to u plus c. When we revert back the u, it will be e raised to 2x plus 3 over 2. 2 is the integral coefficient. That's all for that. We can move to the 17th problem and see what it says. I is x over x dx for us over e raised to x squared. I told you that you may have, of course, it's very clear to us that x is simpler function, e raised to x squared is a better complicated function. Now, in the better complicated function, we are not going to pick up the whole thing and call it as u, but then we'll judiciously pick up one part of it that will help you to get the derivative quicker. So, it's very clear because there is this x dx here, it's better to take x squared. So we will do one thing. We'll make a substitution of u as x squared. If that is the case, our derivative du over dx is going to be 2x dx, 2x. And we can quickly see that there is an x dx that is required there. So we'll quickly take the dx on that side. So you get du over 2 as x dx. And that way when we get the I value, let's check the I value. I value is du over 2. And there is this e raised to u now because x squared is u for us. So that's all about it. So you can take the 2 out. So it's like e raised to minus u du. And you know that the integral e raised to ax has got the integral value as e raised to ax over a. So here it's minus 1, that is a here. So therefore you are going to get e raised to minus u over minus 1 plus c. So it's going to be minus 1 over 2 e raised to minus u plus c. Let's revert back. Minus 1 over 2 e raised to u means x squared, e raised to minus x squared. plus c. If you can leave it like that, or if you want, because it's like negative exponent, you can write e raised to x squared in the denominator. That way also it's okay. That should be all for this video with these 3 problems. With more problems, we can meet in the next video, and it's going to be quite like sway through affair, because as I told you, it's okay in the exercise when you know that you're going to have only substitution, but it is very important that in the exam we should be able to trace and do the substitution. So that has to be there. So with the next category of problems, let's meet in the next video. Thank you.